Okay. So today we are going to solve a problem on gas turbine. So whenever you have some problem on gas turbine, first and foremost what you have to do is to make a your graph. Okay, what is this graph called? It's a Brayton cycle. And what is this Brayton cycle graph? It's a graph between the entropy versus temperature graph. It's a graph between the entropy versus temperature. First, you must draw this figure. Okay, how the temperature changes with respect to entropy on different components. What are the prime components in gas turbine? First is a diffuser, followed with a compressor, combustion chamber, turbine, and then nozzle. Now here I have given the component name. First, when we say ambient or when the air is directly entering inside the diffuser, we call that air is called as an ambient air. So we have given a letter like A. Now the exit of diffuser is the point 0, 1. Now here we have prime and 0, 1 prime and 0, 1. What is this two different letters that signifies that this prime refers to the isentropic and 0, 1 refers to the actual condition. Please note down. Now, exit of diffuser is also can be stated as the entry of a combustion compressor. Exit of compressor can also be stated as a entry of a combustion chamber. Exit of combustion chamber can also state as a inlet of turbine. So if in your problem they are stating the inlet of turbine, so that means this is your notation, that is 0,3. If they say temperature 0,3, if they are stating that temperature is turbine temperature, so you have to state that 0,3. Exit of turbine is 4, and exit of nozzle is 5. So according to this, the problem has been stated over there. So what are the given data in this particular problem? They have given a Mach number, ambient pressure, ambient temperature, pressure ratio. They have given T03. What is a T03? Means there's a turbine inlet temperature. So that's why I have written T03 equals to 1200 as per the given data. Then they have given several efficiencies. So what is the efficiency they have given? Compressor efficiency, turbine efficiency, diffuser efficiency, then nozzle efficiency and mechanical efficiency. And also the last, what they have given the change in pressure. They have given the change in pressure loss. They have given in terms of percentage. So if I have to convert the percentage to the fraction form, I can write 0.04, the change in pressure. Now, here they have given the pressure loss occurring in the combustion chamber. Now, from where the pressure loss is occurring? From 2 to 3. From 2 to 3. So, that means the change in pressure between the 2 to 3 is the 0.04. Now, which one is a higher? P2 is higher, P3 is smaller. So, that means the difference of this is 0.04. So, first and foremost, your prime task is to write down the given data and this one. And if you are like for your semester exam, if it is a long question, 10 marks or 16 marks. So this is an important thing to draw this TS diagram so you can properly map the given data. Now we'll start that how you can start solving the problem. First, we will start with the first component and we will follow the sequence. And before following the sequence, first we have to understand what we have to find. What is your given data and what we have to find. In this problem, they have said to identify that what is a thrust. You have to find the thrust. So if this kind of problem is given and they have asked a thrust, it is going to be a long question. It cannot be done in a single thing. So before proceeding to find how to find thrust, basically what is a thrust? Basic formula that m dot v. Both are needed. Now we need to find the exit velocity. Inlet velocity is given 0.8. We need to find exit velocity. That means at the exit of the nozzle, what is our velocity? To find that velocity, we should start step by step procedure starting from the first component, diffuser, then we'll go for compressor, combustion chamber, turbine and nozzle. We should follow this sequence. And here I'm going to state you the proper procedure how you can solve this problem. So first, solution, we are going to start, write your component. Write your component. In some questions, they will not give a diffuser efficiency, they will say RAM efficiency. They will say intake efficiency. So on that time, both are same. Either diffuser, RAM or intake. All means the same. So what now? First thing, they have given the diffuser efficiency. So we will write the diffuser efficiency. What is diffuser efficiency? First we'll implement that formula. What is the formula? Anyone can say? I by A. What is mean by I by A? The change in temperature of the isentropic to the actual. Now, I can reframe this I by A by seeing this figure. Now, what I have said, the isentropic temperature changes and the actual temperature changes. Which one is higher? T01 is a higher one. So, T01 prime, because prime means isentropic condition, minus TA. And here, it's an actual condition, that is T01 minus TA. Right? Now, we will see what are the given data to us. According to the given data, this diffuser efficiency is given, provided to us. Then TA is given. Here TA is given, the ambient condition. Now, what about T01 and T01 prime? It's not given. Now, there is another total to total relation, isentropic relation I have given. Can anyone tell me? There is another relation, T01 by TA equals to 1 plus gamma minus 1 by 2 m squared. What I have said, previous numericals, that this formula, this total to static isentropic relation will be utilizing two conditions, one in the diffuser, one in the nozzle. So now TA is known to us, given in this data. Mach number is also given. Now gamma, this process is not given, so we'll take gamma is constant as 1.4. So gamma is also known to us. Now from this given data, we can, what is the unknown factor? Unknown factor is T01. So can I find T01 from here? So if I substitute all the values, T01 equals to TA value is 223.3, 1 plus 14 minus 1 is 0.4 by 2, Mach number is 0.8 square. Quickly find out and tell me the answer. Any confusion till here? So here what is happening? I just know the basic formula, substituting the unknown. Second point, for the problem where Mach number is given, I am going to utilize this equation. This is a common principle for any problem for the gas turbine engine. This is a common procedure. If you don't have either of these two, utilize this formula to get unknown factor. And one more positive factor, Here Mach number is given, substitute the Mach number value, you will get T01. After you get the T01, what you're gonna do, you're gonna get substitute back over here. Sorry, not this one, it's a T01 prime. You will substitute over here. So once you substitute here, what will you get? Now diffuser value is 0.93 equals to, then T01 is unknown, minus 223.3 Kelvin, minus, you will get the answer from the previous formula, you will get 223.3. What's the answer? 251. Very good. So here you are getting 251.88. So I am taking approximately 9. So 251.9. So I got my value over here is 251.9. This is T01 prime, which I need to find out. So T01 prime equals to, can I say 0.93 into, just subtract this value and tell me the answer. Is done. This I have multiplied here, this I have taken, plus 223.3. Solve this and you will get this T01 prime. Now, what you have to do, from each and every component, you have to find the inlet and the outlet temperature and pressure. For each and every condition, what you have to do, for the diffuser, compressor, combustion chamber, turbine, nozzle, when we are going in a flow, for each and every segment, what you have to do, you have to find out the temperature and pressure, the unknown factors that is not given in the given data. Now meanwhile you find, I will move to the next is a pressure for this diffuser part. Now pressure, how we can find? Inlet pressure is given. Pressure is given. Whether I know P01, P01 is not given. So what I will utilize, I will use an isentropic relation. Many of you have heard this relation. It's a very simple relation between the ratios of temperature and ratios of pressure. So T01 by T equals to P0 by PA gamma minus 1 whole divided by gamma. You know the value of gamma is 1.4. PA's value is given in the problem, that is 0.2650. P01 is unknown. T0 value you will get it from here. TA is given 223.3 Kelvin. Gamma is here is 1.4 minus 1 divided by 1.4. So if you calculate what you are getting, just quickly tell me the answer. So you got this answer, T01? 249.24. Tell me. 249.8 Kelvin. Alright. Now you have this value here. Meanwhile, substitute this value over here. Now we know this T01 prime value as well. 249.8. Okay. Make this ratio 249.8. 249.8 divided by 223.3. I am getting here 11.1.18. Okay. Yes. And this side P01 by PA is 0.2650. But here we have a power of 1.4 minus 1 divided by 1.4. It's coming 0.285. This is equal to 0.285. Now, so when I'm bringing to the other side 1.118 power, I have to make it as a reciprocal one. I have to make it as a reciprocal one. So when I reciprocal, it will be like, just see whether you are getting the same value or not. 3.5 into 0.2650 equals to P01. Just tell me the answer of P01. Point 0.391. Very good. 0.391 bar. This unit, when you are going for an semester exams or other exam, this writing unit plays a vital role, because everything here, the PA value is in bar. So this is our answer. Okay. Now our diffuser is done. So here write separately diffuser and write the temperatures. T01, what's the value? All the values write it here. T01 prime is, what is the value of T01 prime? 249.8 Kelvin. P01 is 0.391 bar. Now whatever we have calculated, I have written in 1 point. Because PA is given, TA is given. So I am not writing those parts. So diffuser part is done. So I am rubbing this diffuser thing. Thus, likewise, we are going to solve for, what is the next component? What's the next component? After diffuser, what we have? Compressor. Very good. So now I am going to write here compressor. Now what I am going to write? Compressor. Is it visible?
Okay.
Now, again what I am going to do? Here we have utilized this one. We have already utilized this thing. So I will tick mark for my, that what are the things I have utilized it. Next, compressor. Again what we do? We will utilize the efficiency thing. That's the best part. When they have given efficiency, we'll use the efficiency. Now, again what is the formula of compressor efficiency? Temperature difference between the isentropic relation over the actual relation. That is, we say I by A, in short, to remember it. So, now, what is this I? I is the temperature change of the isentropic. I will take from the higher value to the lower value. So, T02 prime minus T01. I will take from this point, right? T01. Now, actual becomes T02 minus T01. Simple. Now, let's check what other values are known to us. Here, T01 is known. T01 is known to us, given we found from the previous data T01 value. Eta C value is given. From here, we can utilize it. Now, again here the issue is T02 and T02 prime. But here for the compressor they have given the pressure ratio. That is RC is given pressure ratio. So what I am going to take here, before substitution, first simplify it. Because once you substitute the value, it's going to be more complicated. First you simplify and you substitute. isentropic relation. Fine. What is the isentropic relation? Same. T naught 2 prime by T naught 1 is equals to pressure ratio between P naught 2 by P naught 1 is nothing but the RC, that is the pressure ratio. P naught 2 by P naught 1 is your pressure ratio. Now gamma minus 1 by gamma. So what is this gamma value? We already previously calculated, that is 0.286. Already you have calculated previously. So in place of this P naught 2 by P naught 1, I am going to replace this. How I am going to replace this? With the RC. Because RC value is given. All of you are following? Now this is known. This part is known. T naught 1 is known. What is unknown from here? Quickly find out and tell me. So I can write T naught 2 prime equals to RC is 8 power 0.286 into T naught 1 is 251.9. You will get the value of T naught 2 prime. And then once you find the T naught 2 prime, you can substitute here and you can find the unknown. And to find the unknown, what are the ways? T naught 2 prime minus T naught 1 equals to, I will just directly substitute the value over here, 0.87 into T naught okay, so sorry, we are finding this T naught 2, right? So the value of T naught 2 will be here and minus, what is T naught 1? 251.9 divided by the efficiency, that value is 0.87. This value is also known to us. So I can take it to the other side. I'm just simplifying it over here. T naught 2, the minus. So total plus of T naught 1, that is 251.9 again. So once you find this T naught 2 prime, that value will become here. So we can find this T naught 2. What is the T naught 2 prime value? 456.57. Let me check once. What's the value? 456.57 Kelvin. Now same I am going to substitute here, 456.57, and I am going to solve this to find out the T naught 2. Check the value of T naught 2. 487.
487.15.
Yes, very good. 487.16 Kelvin. Now from this compressor, we know the value of exit. We know the value of inlet already we have found from the previous. What about the pressure? Pressure, we know the pressure ratio. But do we know the separate values? Do we know the P naught 1 value? Do we know the P naught 2 value? Yes. P naught value we know from the previous, it's 0.391 bar. What about P2? Is unknown. So we need to find out the P naught 2. How? The RC value, the pressure ratio value is 8, which is nothing but the P naught 2 by P naught 1. So to find P naught 2 equals to 8 into P naught 1 is 0.391. Tell me the value. What is the 3.128 bar. So you got your answer. Now for the second component, let me write the component wise. The second component is your compressor. Okay. For compressor, what we know, T naught 2 and T naught 2 prime. What's the value? T naught 2 we got 487.16 Kelvin. T naught 2 is 456.57 0.57 Kelvin. P02 we got 3.128 bar. Now, as of now, we got the two components. The same procedures will be followed in the upcoming components. Now you see, for combustion chamber, no efficiency is given. For combustion chamber, no efficiency is given. Only the pressure ratio is given. Pressure loss. So, what is happening in the Brayton cycle? From the P2, it is decreasing to P3. So, P2 is always greater than P3 concept. This is a concept. P2 is always greater than P3. Now, what we can find? Then can I find P3 value from here? We have given pressure loss for the compressor. Let me write here. Next component is our combustion chamber. Okay. Now combustion chamber, both the values are given. Now the inlet value T02 we got it from the previous one 487.16 Kelvin. In a given data T03 is given. In the exit value that is 1200 Kelvin. 1200 Kelvin given. Now what is the unknown? P3. To find the P03 we have to find. The pressure loss is given. As per the given data, pressure loss P2 minus P3 is 0.04. So if P02 minus P3 is 0.04, then can I find P03 from here? Yes? So P02 minus 0.04. So what is P02 from the previous 3.128 minus 0.04? Tell me the answer.
3.088.
3.088 bar. So now for the combustor, so T03 value is already given in the given data. P03 is right now 3.088 bar. Simple. Now two more components are left out. I am just rubbing this part. So to move to the next component. What's our next component?
Turbine.
Turbine. Now, along with the turbine, see, we have one more thing is given is a mechanical efficiency. What is the mechanical efficiency?
0.91.
Turbine is a component that drives the compressor, and that is how much loss, transmission loss between the turbine and the compressor. That is the mechanical efficiency. Now how we can state the mechanical efficiency? When you are coming to the component turbine, we will just first solve the mechanical efficiency, which will be much more convenient. So it's a mechanical efficiency is a ratio between the work done by the compressor and the work done by the turbine. When I say work done by the compressor and the turbine, how I can further represent them? Cp T02 minus T01 by Cp T04 T03, because 3 is a higher one, 3 minus T04. If you don't know this formula, you have to remember this formula. Fine. Now here, do you know the values? P03 is, P02 is known from here. T01 is known from here. T03 is given in the data as well as over there. P04 is unknown. Mechanical efficiency is also given in the problem. Now it's very easy to solve the unknown. 0.99. Now CP value is not given in the problem. If given, remember the value of CP 1.005 kilojoule per kg Kelvin. Where you need to convert it 1005 joule per kg Kelvin. Now as here the values are not given, we'll take both for the turbine and the compressor is same. We will simply cancel it off. This is a value. Now I will substitute this. What is T0 2 value? 487.16 minus 251.9. And what is T0 3? 1200 minus T0 4. From here I can find the unknown factor T0 4. Can I find the unknown T0 4 from here? The difference between 487.16 minus 251.9, and then we have 0.99, then we have, now it's minus. Is it okay? Tell me the answer. Solve it and tell me the answer. This is just I have replaced this value. I have just replaced this value. When I interchange this thing, right? I will get like that. Because 12,000 minus T0 4. Then here we have, right? So when I interchange this thing, I will get this value. Tell me the answer. Let me see. 487.16 minus 251.9. We get this one is 235.26 divided by 0.99. We get minus, so 1200 minus 237.63. Let me check and confirm me the answer. Are you getting the same? 962.36 Kelvin. T0 4. Is this the value? Huh? You're getting the same value. Alright. So now we have this T0 4. Okay. Now for the turbine, one component we know it. Now this is how we got from the mechanical. Mechanical means when we see actual reaction when turbine is rotating and how it is impacting on the compressor. Now we will go with the turbine efficiency. Now we'll go with the turbine efficiency, eta T. What is eta T relation? Actual by the ideal or the isentropic. Ideal means, here we have actual means what? This is an actual reaction. T0 3 minus T0 4. Then ideal means T0 3 minus T0 4 prime. Now here we know all the values. T0 eta T value is given in the problem. T3 value, whatever T3 value is known. T4 we got it from here. T3 is again known. Now can we find the T0 4 prime value? Now similarly we can find the pressure as well. How? We have to utilize that. Meanwhile, solve this isentropic relation. How we can find isentropic relation? T0 4 prime by T0 3 equals to P naught 4 by P naught 3, where gamma minus 1 by gamma, where gamma value is constant. So I'm directly writing 286 value directly. So once you find T naught 4 prime, you just substitute here T naught 3, then P naught 4 is known. So from here you will find the unknown value. So when you find the relation T naught 4 prime by T naught 3, if you inverse this, you will get 3.5 multiply P naught 3 equals to P naught 4. So basically this will be your formula to find this P naught 4. You got your answer? P naught 4 prime? 935.95 0.95 Kelvin. You got your answer here. Now substitute over here 935.95 by 1200 power 3.5 into P naught 3 is 3.088 and you will get your P naught 4 value. Now quickly tell me what is P naught 4. So meanwhile let me write the turbine values. Turbine is T naught 4 value we got is 962.36. T naught 4 prime is 935.95 Kelvin and P naught 4. I'm waiting for your answer. So solve this problem. You will get this 1.293. So this answer is 1.293 bar. So here is 1.293 bar. So it's clear? So turbine, how we have solved? We have solved again with the same procedure. It's not mandatory that which one you will take first. You can take vice versa also. You can take. The moral of the story is if you take this one first, here you will get two unknowns. So again you have to come back to this. So but when you are taking turbine, remember if mechanical efficiency is given, you have to take this. If not given, you have to take 100%. Fine? If not given, take 100% and you will find. And the procedure to find pressure is using the isentropic relation. This is a common procedure for all the components. Now we have moved to the last part of our this component. What is that? Nozzle. Now when we are into nozzle, when we are going into the component of nozzle, first and foremost we have to identify whether this nozzle is choked or not. Okay.
Going.
This condition we have to find whether his nozzle is choking or not. So what is the formula for this? The choking condition P naught 4 by PA is greater than P naught 4 by PC. Has to be greater. What is PC? The nozzle choked condition. If this condition satisfied, that means P naught 4 by PA ratio is greater than this P naught 4 by PC. That means that nozzle is choked. So before proceeding to the other nozzle values, this you have to keep in mind that whether the nozzle is choked or not. Now to check this, P naught 4 by PA value is known. P naught 4 value is here, PA is given here. You can find this value. What about this P naught 4 by PC? There is a formula. You have to remember and find out this value. It's slightly complicated. So you have to remember and write down this formula carefully. 1 minus 1 by eta n gamma minus 1 by gamma plus 1 whole whole power gamma by gamma minus 1 gamma by gamma minus 1. This is a formula. This is a formula that to identify the value of P04 by Pc. So write down the conditions of this and tell me that and tell them and find out, you know the value of nozzle efficiency, it's given in the problem. Gamma value, what I have said, is constant, take it constant is 1.4. Okay. So quickly let's find out the value then. P04 by Pc equals to 1 by 1 minus 1 by, what's the efficiency value? 0.95 by, I'm just quickly writing 1.4 minus 1 is 0.4 and plus is 2.4. Then we have gamma by gamma minus 1. That means power of 1.4 by 0.4. That is 3.5. I can say that. So quickly solve this and check that the ratio of P04 by PA. What is the P04 by PA? 1.293 by 0.2650. Quickly check this value and the other value and you can find whether the nozzle is getting choked. And what is the meaning of this nozzle is getting choked? That means that at the throat section, the Mach number becoming 1. What does that mean? If it proves that it is choked, that means Mach number is happening 1 at the throat section of a nozzle. That means the exit value of the Mach number, that means V5, the exhaust value means it's a Mach 1. Mach 1 means again the value of, when I say Mach 1, what does that mean? That VE, to find in terms of velocity, you have to use this formula. TE or T5 you can say, exhaust or the exit temperature. So quickly tell me whether this nozzle is getting choked or not. What's the ratio between this P04 by PA?
1.964.
Huh?
1.964.
1.293 divided by 0.2650. So let me see, 1.2943 divided by 0.265. It's coming around 4.879. The ratio is 4.879. What about the other one? P04 by PC? 1 point, yes. This is coming up 1.964. Okay. Now, there is a drastical difference as you can see. What the difference is? That in this formula, you're getting 1.965 and here. So now, you can tell that this particular problem, what is happening? The nozzle is getting choked. Nozzles are getting choked. So, what you have to do? If the nozzle is choked, that means what is the condition? the nozzle is choked means Mach number becomes 1. Mach number becomes 1. Now, in the starting of this problem, I have said that this is a formula. It will be utilized both at the exhaust and both at the inlet part. This is a formula. This is an total to static isentropic relation will be utilized both on the diffuser and the nozzle part. So now, as the Mach number is 1, if I substitute here, because nozzle is choked, Mach number becomes 1. So what I will get over here, 2 plus gamma minus 1 by 2. So if I rearrange this equation, what I will get, gamma plus 1 by 2. So T04 by T5. If what's the ratio between this is a gamma plus 1 plus 2 by 2. Now T04 is known to you. So can you find T5 right now? T5 is, how you can find T5? Gamma, how you can find T5? 80 96 Kelvin. Good. Similarly, what you have to find? Now you have to individually find what is P5, pressure at this point 5. How you can find? Here we are not going to follow the isentropic relation. We know this relation. We know P04 by PC equals to 1.964. We know this relation. We know the value of P04 from this given data, turbine 1. PC equals to 1.293. 1.293. Sorry. Okay. Divided by 1.964. You will get the PC value. Okay. Point? Very good. 0.658 bar. Okay. Now, for the nozzle, the last component you got all the values, T0, T05, you got it, 801.96, and you got PC value is 0.658 bar. You got all the values. Now, what is our moral of the story? What do we have to find? You have to find the thrust. To find the thrust, our point is to find the velocity. We know the Mach number is 1. Now, how we can find the velocity? We know Mach number equals to V by root over of gamma RT. So, the T5 value will substitute here. The R value, the constant value, we'll put it here, 287. Gamma is 1.4. Mach number is 1. So, basically to find V, that is the exhaust velocity, is nothing but the root over of gamma RT5. Root over of 1.4 into 287 into value of T5 is 801.96. You will get your velocity. Okay. So now you know that the velocity, the thrust is a difference between the exhaust velocity and the inlet velocity. You can find in terms of Mach number, convert the velocity. Here you will get the velocity. Now, as a Mach number, as the mass flow rate is not given, either you can assume it or take this thrust to mass flow rate value and you will get the answer of the thrust. Okay. This is how you have to solve this problem. Clear? So step by step you have to move on. Same formulas, application of same isentropic relation, and at the end nozzle part you have to check whether the nozzle is choking. If choking, you have to consider the Mach number is 1. Considering this Mach number 1, we have to find these ratios and find the temperature. If it is not, whatever might be, then what you have to do, we have to follow with this P naught 4 by PA value, and the whole procedures will be followed up to find out the answer of the exhaust velocity. Okay, I hope you have understood and you can check this video.